Okay, so to just kind of wrap up 9.5, or at least the instruction piece on it, and then you guys will have plenty of time to work. Characteristics of tangent and cotangent. This is in your student journal. I believe it's on page 264 and 265. Okay, but I'm assuming you've read through this. These are your notes. It's a good place to add. As you read through, these are all things we've talked about, just kind of in a, maybe in a different wording. So the domain of y equals tangent is all real numbers except odd multiples of pi over 2. At these x values, the graph has vertical asymptotes. So you're talking 1 pi over 2, 3 pi over 2, 5 pi over 2. And if you think of the unit circle, that's where sine is equal to 0, which means your denominator for tangent is 0. Or tangent, cosine equals 0. Sine over cosine. Okay, so that's when cosine is equal to 0. So your denominator is 0. At 1 pi over 2. So if you're like odd multiples, what are they talking about? Well, it's just 1, 3, 5, 7, and so on. Pi over 2. So this is really just summarizing everything we've kind of went through. The domain of y equals cotangent is all real numbers except multiples of pi, because at pi, you have 0. So 1 pi, 2 pi, 3 pi. Remember, cotangent is the reciprocal of this, so it's cosine over sine. Okay, so that is when sine is 0. Sine happens to be 0 at pi, 2 pi, 3 pi, and so on. So that's where it's undefined. So that can't be included in your domain. The range for each of the function is all real numbers. Okay, they continue to move up and down forever, which means they don't have maximum minimums, which means there is not an amplitude for a tangent and a cotangent. The period of each graph of the parent function is pi. Remember, period it's pi over, what's the formula there? Pi over b, which in this case, if b is 1, in the parent function, it's pi over 1. The x-intercepts for y equals tan occur at plus minus pi, plus minus 2 pi, plus minus 3 pi. These are things you may not be thinking about, but as you look at your graph, you could easily see the x-intercepts at these places. And note, we never actually graphed. We always did our graphs in positive, the positive world of x or theta over here, but there's that whole other world over here, which is our negative values of x and theta. We never went over there, but it's just a reflection over the y-axis if you have that negative. Okay, and the x-intercepts for cotangent are shifted 90 degrees, so it's pi over 2, 3, pi over 2, and so on. Okay, so you have your summaries there for tangent and cotangent. This is only helpful if you know what they're talking about, which means you should try to annotate it and make it, at some point today, make it good notes for you, valuable notes, rather than it's just you reading someone else's notes. Okay, if something doesn't make sense, draw a line through it and write it in your own words. If it pretty much makes sense, it just helps you by adding a little piece to it, add a little piece. Okay. If you look at the next page, they talk about period and vertical asymptotes of AB. Is this on the next page or just the bottom of that page? Okay. So the period of the graph is pi over b, which we already referenced. The vertical asymptote of odd or pi over 2b, and the vertical asymptotes of cotangent AB to x are pi over b. Okay, some things we've kind of talked about. Once again, just annotate it to make it your own. When you talk about secant and cosecant, I'm not going to go through the whole piece that I just did with cotangent and tangent, but walk through it the same way. Okay, it talks about the same stuff. Okay, multiples of pi over 2. Please note that the secant and secant do not have amplitudes because they never stop increasing or decreasing. And also note that the range, or excuse me, the range here is y is less than or equal to -1 and y is greater than or equal to 1. Where your sine curve would exist or your cosine curve would exist. So if we did a quick sketch, just maybe of our cosecant. Okay, so the cosecant, remember, is going to just encompass this part of your graph, here and here. It does not include the sine curve, which fluctuates from 1 to -1. Okay, so that means your range does not exist between 1 and -1. Okay, for cosecant and secant. Yeah.
And so that means if the amplitude was like 3, it wouldn't exist between 3 and -3?
Right, it wouldn't exist between whatever your a term is. Yeah. So in this case, since we're talking about the parent functions, it won't exist between 1 and -1. But yeah, if it was 3 here, it wouldn't be between 1 and -3, or 3 and -3. Yeah.
So I understand why it doesn't exist for cosecant, but isn't secant only existing in that range?
No, sine is.
Or sine. Sorry.
Sine is
Okay.
existing, yeah. So secant and cosecant won't exist. Okay. The period of each graph is 2 pi. It's same as sine and cosine. Remember that secant and cosecant and cotangent always share a common point. They share that one common point with their reciprocal functions. What is that one common point they always share? Yeah. Matt? Yeah, your a term. They always share a. Whether it be here or here, or when you're dealing with cotangent, tangent, you share that a term, always. So you'll always see that on your graph there. Okay? Then we move on here. Next page. This again has characteristics. Oh, excuse me. This was page 264. It also has that's the previous page. It also has your vocab terms up there that you can define. Okay? All right, I just wanted to go through that because a lot of times, especially in books like this where they give you student journal pages, they've essentially taken notes for you, which, quite honestly, I think is good in some ways, and I think is very bad in others. It's good if you're a person that can annotate notes and write all over and make sense of what they're saying, because you're reading it and you're analyzing it and you're kind of questioning things. You're making notes to yourself and then clarifying the things that you had questions on. That's important. That really is more like college, where you buy a textbook that you can write in because you have bought the book. It's your book. Okay, maybe you buy the answer manual. It's your answer key. Okay, it means though that if you're not taking notes, then you're highlighting in the book, you're making notes in the margin, you're doing all those things to help yourself understand it. If you just say, oh yeah, here are my notes, that is not helpful. So maybe you don't even use this page. Maybe you've taken notes somewhere else and you're like, that's just too confusing. I'm going to use the notes I have. That's fine as well. Okay, but don't try to go back the day before the test and read something you've never read before and think that it's going to make sense. Okay, so that's why I want to go through those real quick. Any questions on that? Wow. All right. Here we go. So extra practice on page 266. Hey, we finished this yesterday. The thing we didn't talk about yesterday were the actual shifts. And many of you didn't write down the shifts, because I just asked you to do the graphing piece on it. But let's make sure that we're clear. This still is a horizontal shift, right? This is a horizontal shrink of 1/2. It's always opposite when it's in there with x. So it's a shrink of 1/2. This right here is a horizontal stretch of 2, the reciprocal of it. And outside is vertical, and since you're multiplying, it's a stretch of 2. Here is pi over 4 greater than or less than 1. Less than. 3.14, 3 divided by 4, approximately. Okay, but it's less than 1. That means this is a stretch, because it's backwards inside with x. And then you flip it. So it's a stretch of 4 over pi. And then outside, you're multiplying by 1/4. And it's vertical shrink of 1/4. Okay, on number 4, inside, shrink or stretch? Shrink of 1/3 and shrink of 1/2. So horizontal shrink of 1/3, horizontal stretch or vertical stretch or shrink, excuse me, of 1/2. Man. All right. Next one, number 5. The 2 is what type? Vertical or horizontal? Stretch or shrink? Shrink of 1/2. Vertical stretch of 2. Okay? And the last one, number 6. Horizontal or vertical? Horizontal, stretch or shrink? Shrink of 1/2 pi. Okay. Hopefully those have become a lot easier this year. Guys, I promise you that knowing the horizontal and vertical, and especially the horizontal and stretching and shrinking, that's going to help you a lot next year in math analysis. You're going to be like well ahead of the game there. Okay? All right. Last piece before I let you go. Any questions? Not problems you didn't finish, just questions. Like you're like, I didn't understand what they're asking here or what we're supposed to do. Yeah.
I have the graph for 4, but I feel like it's wrong. It just doesn't look like
Okay, we check it before you feel like it's wrong. But like check it on the board. Like if you're not sure how to, I just want like I didn't even know how to start that problem. Okay, we're not going to correct it as a class. You can correct it individually, but yeah. Number 10. Okay. So cosecant of pi over x. So the first step in graphing cosecant, secant, or tangent is to graph their reciprocal function first. So the reciprocal function of cosecant is sine. So I'm going to go f of x and say use g of x. I'm going to graph 4 sine pi over or pi x. Okay, and that pi right there, if I'm dealing with my a, b number of cycles in p, well, a is 4, b is pi. That means the number of cycles is, when we're dealing with sine, is it the same or is it twice? It's the same. Yeah. So b and number of cycles are the same with sine, cosine, secant, and cosecant. With tangent, it's twice as many. You have to multiply it by 2. So we're going to see about 3.14 cycles. And the period is 2 pi over b, which is 2 pi over pi, which is 2. So each cycle we see is going to be 2. So now I'm gonna graph the sine in pen. I'm not going to graph the cosecant. I'm going to let you finish that one. Do not graph in pen because you should actually erase. Okay? But for here, if I'm graphing 4 sine pi over x, I've got my 0, my max, my 0, my min, and my 0. So that right there is my 1 cycle. Okay, so at this point, I have a length of 2. They've asked you to just graph 1 period of it. So that means I've graphed 1 period. It just happens to be 1 cycle. Hey, you 3.
Sorry, I was trying to get that and then you stole it.
Okay, hold on. Probably not the best time to even do it. Okay. All right. This is 2, so we've graphed 1 cycle. We don't have to do any further because we've graphed 1 cycle, which is 1 period length. And then from there, you're just taking on your cosecant curves off the top and the bottom. Okay, so you just grab this point, throw in your asymptotes, and put your little horseshoes, and then erase your sine curve. No, hey guys, I'm not telling you right now, I am not making you be exact on where your points are on your little horseshoe things. I'm just letting you put the little U shape on the top and bottom. Okay? Next year you will get more exact with that. For this year as learning it, we're just going to that extent. Okay? When we graph them on your portfolio, graphing portfolio pages later this year, I'll actually have you get a little stricter about it. Okay? Yeah?
Do we need asymptote by that first?
Yes, you should have an asymptote here as well. Okay? And then make sure you're labeling. So if this is 2, this is 1, this is 0. Okay? Good. So I said I wasn't going to finish that one, but I did. The only thing I can't do is erase the sine curve because I did it in pen. You guys should erase it. All right, other questions? Okay, very good.